There are many different ways to measure how long something is, how large something is, and how fast something is. Overall, linear motion. This is where we have either scalars or vectors. Scalars are a quantity that shows the size of something. Some examples of this could be mass, speed, or distance, as it only focuses on the size of it. Direction is not included in this. For example, when someone has a mass of 50 kg but a weight of 500 newtons, is because of the gravitational field strength. This is because the mass of something doesn't require any force of direction showing that nothing acts on it, therefore it is a scalar. However, a vector describes size and direction. Therefore, in the example I just said about the mass and the weight would be the vector as the direction of the gravity pushes down, pushing down, acting on it, therefore the size and direction is included. In biomechanics, there are many values that are similar, but one is a scalar and one is a vector. For example, distance and displacement. Distance is the distance covered that someone has gone from one point to another. It would measure how far the person went between the 2 points. Distance is a scalar and does not care about the direction the person is going, it will just follow anywhere the person has gone. On the other hand, there is displacement. Displacement is the quickest distance from A to B. This can also be known as the bird's eye view. As you can look from the top left image, it shows the distance and displacement from A to B. The displacement is the direct route, and the distance can go in any direction as long as it reaches B at the end. For example, in basketball, one player may be dribbling with the ball in the corner of the court, and then he decide to run around two sides of the court and end up the opposite diagonal end of it. If someone wanted to measure the distance of the player, they would record exactly the route the player went. However, if they wanted to find the displacement, they would look at the start and the end of where the player was, measure the direct route of it. Therefore, showing the distance only requires the magnitude of how fast the person has gone, how far the person goes, resulting in it being a scalar. And then with displacement, this is only showing the direction of the quickest route between 2 points, therefore including direction and magnitude, resulting in it being a vector. Another two values that are very similar are speed and velocity, where speed is a scalar and velocity is a vector. The reason behind this is because speed measures how fast someone has gone given the distance they have travelled, and velocity is measured given the displacement. This then means that the velocity includes the direction as well as the speed. To calculate speed, you would need to find a distance and then divide it by the time taken. To calculate velocity, you would find the displacement and divide it by the time taken, as velocity measures the speed in a direction. In the example, the basketball player running to the opposite diagonal end of the court, which travels around the edge of the court. To find the speed of the basketball player, you would find the distance and then you would measure the time the player takes to get to the point, take both measurements and divide the distance by the time, which will give you the speed. And then the same will apply for the velocity, but divide the displacement by the time, that gives the direction as well. Therefore, this shows that speed and velocity are slightly different due to speed being a scalar and velocity being a vector. Another value to measure linear motion is acceleration. Acceleration is a vector which measures how quickly someone or something is speeding in a direction. To calculate acceleration, you would find the velocity and velocity at the end of the motion minus the velocity at the start of the motion, or at the point that you want to take the data from. You would divide it by the time taken during the motion, and So to calculate acceleration, you would need to find velocity at the end minus the start, and then you would divide it by the time taken during the motion, and that will get you the acceleration. So it would be the end velocity minus the initial velocity divided by the time taken. In contrast, there is deceleration, which works exactly the same way, but it measures the slowing down instead of the speeding up, but it uses the same equation. In basketball, someone may calculate acceleration of a sprint of a player, and they would measure the velocity at the and at the end of the sprint. They would measure the time and then divide the difference in velocity by the time, and get that basketball player's acceleration. Therefore, acceleration is a really good way to measure how quickly some players can pick up pace compared to others who may take a bit more time to get their max speed. When collecting the data, such as perhaps time and distance travelled and even acceleration, we can place them in different types of time graph. One way we can show speed and distance, we can use a distance time graph. Many analysts use this to compare these types of graphs to look and compare different people in their speed. This type of graph is a great way to illustrate speed, where the x-axis is the time and in seconds, and the y-axis is the distance in meters. As the equation for speed is distance divided by time, you can get a point on the line and see what the distance is and the time at that point. You would then use the equation to find the speed. If the line is horizontal, then the person would be at rest. If the line is going diagonally up, then the person is going at a steady speed. So as you can see on the left, there are also curved lines coloured in red. This represents acceleration that someone is travelling, as the speed would be changing at all times, resulting in the line being curved. If the curves get more vertical, then the person's acceleration. However, if the curves get more horizontal, then the person is decelerating. For example, the distance time graph could represent 3 different basketball players running. The person that represents the green line would be running the same speed the whole time. The person that represents the blue line starts running at the same speed, stops for a bit, between 5 and 9 seconds, and then runs at steady speed again back to his original position. And the person that represents the red line accelerates up to about 8 seconds, which then they decelerate until they stop. Therefore, distance time graphs can show that many different types of data and compare many athletes by plotting their information on the graph. Another type of graph to compare data is velocity time graph. This can be also known as speed graph. These work slightly differently to distance time graph, as it would be velocity on the y-axis instead of the distance, where time is still on the x-axis. An example of velocity time graph is shown on the right. The blue line represents someone constantly accelerating as the velocity is constantly increasing at the same pace. At the start of the red line, the person accelerating. However, at 4 seconds, the line goes flat, which is showing that the person's velocity is constant. This is present until 7 seconds, when the line is going down at a constant rate, meaning the person is decelerating. This graph is a good way to find out what the acceleration is by finding 2 points on the y-axis. Find where the 2 points hit the line and it will give you the time. You would then do the final velocity minus the initial velocity and divide it by the change in the time, which gives you the acceleration or deceleration of that person. This can be used in basketball when people may look at these graphs where multiple lines may be used to compare different types of players. As a result of these two graphs, they can really show people the visuality of results compared to perhaps in a table where they give people an easy understanding if they analyse results of perhaps basketball players running.